Hello everyone, so now let's look at our question 13. So number of supercomputers takes n hours to solve a supermath. So do we know how many supercomputers do we have? No, we don't know. So here's the first question mark here. And if two more supercomputers join, it will take 7/8 n hour to solve the task maybe. So if two supercomputers are not working, it will take 2/3 hours more to solve the math. How long will it take in hours for one supercomputer to solve the super math? So you see, in this question, two very important things. One is the number of supercomputers, and the second one is time. Right? So we can list a table. The first thing is about numbers, and the second thing is about time. So how many what's the number of supercomputers at first? We don't know, right? So we can just use X to represent. And what's the time at first? Yeah, n hours. Use n to represent. And also, if two more supercomputers join the mission, it will take 7/8 n hours to solve it. So x plus 2 is the number of supercomputers now, and it will take 7/8 n hours. So you see, yeah, after that, if two supercomputers are not working, so we will have x minus 2 supercomputers, and it will take 2/3 plus n hours. So we have listed all the key points here. And remember, the task of what we do is never change. So which means the number times the time will never change. So we can follow the condition 1 and condition 2. We can write one algebraic equation. X times n equals to x plus 2 times 7/8 n. So you see, this n on both sides, we can just cancel it. So we can solve out the algebraic equation. X equals to 14. Right? And we know x equals to 14. Then we can represent all the x plus 2, x minus 2 by 14. So this one should be, we can write another algebraic equation to solve out n. So 14 times n equals to 12 times n plus 2/3. And after that, you can solve out n equals to 4. This means for 14 supercomputers, it will take 4 hours to solve this task. So for one supercomputer, how long will it take? Yeah, just use 14 times 4 equals to 56 hours. Okay, here is the method 1, and we just use table to list all the things we know and we don't know, and after that find out the relationship. The task never change. So numbers times time is just constant, will never change. And after that, list the two algebraic equations, find out x equals to what and n equals to what. After that, we can find out for one supercomputer how long will it take for it to complete this task. Okay, now let's look at the method 2. So for method 2, we'll focus more on the ratio relationship. So this one is a kind of engineering problem. So for the engineering problem, the most important thing is the number and the efficiency and the task. So in this question, we can write it down by the task equals to time times the numbers, right? And we know at first, yeah, if we add two more supercomputers, the ratio of time before and after is what? From n to 7/8 n. So the ratio is just 8 to 7. And remember, task never change, equals to time times the numbers, right? So we can also write down the ratio of numbers is on the contrary, it's just 7 to 8. Look at that. 7 to 8, the numbers, right? So the difference is only one part. So one part, how many supercomputers? 2, yeah, 2 supercomputers. One part is 2 supercomputers. So at first, the number of supercomputers, it should be 7 part. So we can calculate the number at first is just 7 times 2 equals to 14. So we have already found out how many supercomputers do we have. And after that, we know the condition. If we minus 2 supercomputers, the ratio of the numbers, do we know that? Yeah, we have already find out. At first we have 14 supercomputers, so minus 2 will become 12. So we know the ratio is 14 to 12, and don't forget to simplify the ratio. It will become 7 to 6. Then 7 to 6. The difference is still 1 part, right? So we need to find, and also don't forget this one. It will take 2/3 hours. So we need to calculate the ratio of time. Yeah, on the contrary, it's same, right? Because we know time times numbers equals to task. Task never change. So the ratio of the time is on the contrary, it will become 6 to 7, and difference is 1 part. So this 1 part is the time. So do we know the time? Yes, of course. It used more 2/3 hours. So we can calculate 14 supercomputers will take 6 times 2/3 equals to 4. So we know for these 14 supercomputers, it will take 4 hours to complete the task. So for one supercomputer, how long will it take? Yeah, 4 times 14 equals to 56 hours. Okay, for this method, we should know about the relationship between time and numbers, and find out the time ratio and the number ratio is on the contrary, and the task will never change, right? So after that, find out the difference between two ratio and then find out 1 part equals to what. After that, use 1 part to time something. You can find out what's the number of supercomputers and how long will these supercomputers take to complete 1 task.